So this is typically roughly what a genset looks like with a radiator system on it. Our genset come in a number of sizes. This one here doesn't have an alternator attached on it on this end, but it's quite large. Radiators can vary in size. This is a single fan radiator made by a company called IEA. And coming around to the front side, this will be the surface or area that we're looking to pull our airflows off of. The grating you see on it is a rock guard, and we extend off the front of this radiator on all four sides around the perimeter a plenum extension. Those plenum extensions are about 24 inches deep. Here's a plenum extension on a different radiator, but a much shallower dimension as far as depth goes. As you can see, we also have some purple wiring, which is thermocouple wire that is made to or is applied to our rock guard on these, and we use that to get temperatures. Moving on into our test cell area, we'll see if we can get you any good ideas of what our test cell looks like itself. Here is our test cell, and we have a 95-liter genset in here right now. This one will have a radiator attached to it in the near future. It's on order, a new design. And when that radiator is attached and the plenum extensions are installed, the unit will push up against what you see here as our plenum or mixing and controlling chamber. Inside that opening is where the air flows off the radiator, and then we either recirculate it or move it right out of the building. There's panels that are removable in helping us to configure the size and shape of this opening so that it fits our radiator, and then we do some sheet metal work ourselves for each setup to get the correct opening size. Moving interior of this so-called plenum chamber, you will see a view from the interior side. You'll see some structural steel there. It's mainly L channels or L angles that are built into these panels that we can remove. But as you get to the left and right, where these adjoin right here, that is a permanent component of the plenum. And it has these diagonal braces that are installed or welded in here on the interior. It also goes up and has a few braces way up at the top, which you can see kind of diagonal braces that come off the ceiling into the front panel. And the same thing all the way down the left side. A few braces, some angle iron, all the way down to the ground. Inside the plenum, it's all concrete, right to the, on the floor, as far as the floor goes. And we are looking to get the unit or the airflow data collection apparatus to work in the horizontal plane, but actually 12 inches inside towards the radiator of this 24-inch plenum I explained. This whole unit is made out of just sheet metal. There's a door that we enter in and out of the area here. Once the radiator is installed up against the front of the plenum, this is the only way in and out. And we have ample room to install some other boxes and stuff, control boxes, what have you, on the exterior of this. So this environment on the exterior of the plenum will only see temperatures of about anywhere from 110 or 20 degrees, let's say, down to, you know, freezing temperatures or below, depending on what's going on in the outside in the environment. Because although this test cell here has heat, it does not have cooling, and the heat can be overridden and shut off manually, which it is a lot of times, and it's just a unit heater that heats the area. That unit heater goes off whenever a genset is running in here. Again, looking at kind of the front of the plenum area as I walk around the genset, and up here above these large tubes that are coming, we create attachments on this and hook up to a left and a right bank of exhaust, kind of like the manifolds on a car. We have a left and right exhaust typically that all our turbos feed into to get the exhaust out of here.